So yeah, it's a very good question. Looking at Hadoop, like you just said, it's very well, it's designed to kind of support batch processing jobs and storing large amount of volume of data. But where the problem comes is how well is it structured to do analytics on top of it. So I mean, as far as kind of storing data and everything, yes, there are a lot of startups actually that have gone the Hadoop way, right? Like OPower itself. I mean, their big data platform is on Hadoop. But I mean, what is it that you could do to build customized adapters or analytics on top of it is, I think, the question. So when we go with these with other platforms, right, where you have a set data model, and then you have these, like I said, you have your either you have your inbuilt analytics, or you have the potential of kind of extending it further to be compatible with tools that are there in the market, is something which what organizations would normally look at. So as a startup, I would say, I mean, I would at least encourage that if there is kind of depending on how the other verticals are also look at it, at least in the energy vertical, we look at startups to provide more kind of value on the analytics side rather than kind of developing something on the platform itself, because that's something which is going to be core to the business. And as they move along on getting kind of moving this needle through different business units with the organization, there are point bank solutions which they'll be looking for, right? So either partnering with kind of established companies and kind of building solutions is one thing, or if you can even look at build new analytic solutions which can kind of basically solve point blank solutions, is what I think kind of organizations will look for.
Joel, did you have a
Yes,
question?
I had a question. Brian, you spoke to this a little bit, but the general question is, to what extent are data scientists the linchpin in big data today?
Do you want to repeat the question? Thank you.
The question is, to what extent are data scientists, or the lack thereof, the linchpin in big data?
Are you a data scientist? Depends on who's asking, right? Okay.
No, I think it's a great question, and it's not just a yes/no answer. I think finding great data scientists and then also the programmers to implement it is quite a challenge, in my experience. And quite often the requirement profile is very, very, very specific, which makes it so hard to find that perfect fit there. But I think that's not the only linchpin there. I think a big challenge still is to find out what are the applications, what kind of analysis do you want to perform, and what kind of business decision do you want to derive from that. Establishing that and the economics behind it. What is really the value, the economic value generated by that application? I think we are still in a phase where for many applications we try to establish that. And there's more mature applications out there. You mentioned the example with the aircraft engine. I think Lufthansa has been doing that for 4 or 5 years or so. So before the plane lands here in San Francisco, they already know what is wrong with the engine. Just because the downtime costs them so much in bringing in a replacement aircraft and so on. I would say in the smart grid, there's a lot of applications there where we still try to figure out what exactly is the economic benefit.
Okay.
And that will just slow down the adoption of that. Right now, a lot of those applications are being tested to see what is really the effort that you have to undertake, and then what is the business impact you can achieve with that. And then we'll decide which of the 100, 200 potential applications will really be implemented, because it's not going to be 200 of them.
Okay, so what you're saying is actually beyond the data
Yeah.
scientists, there's basically a fundamental what are the economics and what
Yeah.
should we be doing issue. Yeah.
And the other thing that I've heard from a lot of our clients are not only do you need the data scientist, but you need a data scientist that has expertise in the sector. right, per se, right?
Yeah,
You
that's the-
want
that's the
somebody who
requirement
really
profile I was talking
understands,
about.
right, healthcare. You
Business
really
knowledge.
want someone who understands the business knowledge and utilities. Somebody who's very well versed in healthcare is not gonna be of value to you. So
And
that's an important
even
requirement.
another constraint to that, which is regulatory, since you mentioned healthcare. You have to live with a lot of restrictions actually, and what data you can use for what purpose, and how do you send it, and all those things.
Right.
So that's not just a technical limitation, that's actually a legal limitation also.
Right, yes.
Yeah, my last question for tonight.
You promise?
I promise. I don't want to-
I'm sorry, I
big
can't
data
see your
questions.
badge. What was your name?
My name is Vikas. So this is for Siemens and GE in the M2M space. So I see big data as of different types. There is the human big data, the Facebooks and with all the chatter that you see on the web. But humans can type only at a certain rate, and there are only so many humans, right? So the ceiling can be determined, and it can somehow be managed and analyzed. But machines are always humming, so they have the potential for generating significantly more big data than human-generated big data. So instead of thinking of the problem as how do we analyze large scale of information, the problem can also be shifted towards the sources of the data. So are you looking at, again, the GEs and the Siemens, building in more intelligence into the sensors so that only data that is of interest, only the temperature goes about a certain point, is it interesting, is it worth worrying about? You emanate only that information to the platform and save everything else, because everything else is noise. So in the M2M space, are you looking at breaking down the problem both at the platform level as well as the data source level?
Yeah, I can only second that, but to your first statement, I think actually humans are capable of creating ever more data, because if we run out of words that we can say during a phone call, we'll start posting pictures, and then it's video and whatsoever. So we always find ways to push data levels further up. But the other point, collecting data for the sake of collecting data doesn't make sense. And clogging up communication channels with gigabytes of data, which don't really contain much information, doesn't make sense either. So that's why pushing some intelligence out to the sensor, to the device, to the edge, whatever you want to call it, makes a ton of sense. And I think also Moore's law is just helping tremendously with that, because you can push more intelligence out there at very, very low cost, provided you find ways to do that securely. That's the one aspect that I always bear in mind, because it's easy to have a one-way, simple data interface, which can be very, very secure.
Right.
The more intelligence you push out, the more you also have to deal with maybe over-the-air upgrades or so. How do you maintain the software out there? You have bidirectional communication, you have a control interface all of a sudden, and you need to implement that in the right way.
I totally agree. That's, I think one of our taglines is brilliant machines, and it's not lip service. It makes a lot of sense to make the edges as smart as possible, and we're even doing that with programmable logic controllers, which today aren't known for their brilliance. They do many different jobs, but there is a great deal of utility in not collecting every single data point, but maybe the ones that you know are most significant. And if you just pay attention to the few that are known to be signal, as opposed to all of them and have to sort out the noise later, you can design systems that are more effective. So I think most people are heading in that direction. If you have the luxury of knowing in advance what to ignore in terms of all of the data, that's great, do that. But that doesn't mean you can always do that. I think you also have to deal with situations where you don't know in advance, and it's sort of a forensic thing later. We have monitoring centers for a certain product that we make that monitor things in real time that people are operating. And one of those has several petabytes of data, and there's 18 of those globally at those centers. And the reason they keep all the data is that forensically sometimes they have to go back. The data is a discrete digital stream, and they have to go back and reverse the waveform that thing came from, because some of the analytics are, only work on waveforms and not discrete signals. So there are some things that you can sort out and ignore, and then there's other things where you just save just in case. And there's not an either or.
Thank you.
Okay, Jeremy.
Well, you gentlemen just answered my question. I was IOTA Computing. We build very, very tiny, secure, remote intelligence for Internet of Things, edge objects, the little tiny smart sensors. I was going to ask you about security. Is that encryption? Is that data security? Or is that also authentication and non-clonability? Is that still my sensor? Has somebody nicked it and put something else there? Is that still my data? Who's listening to my heart rate data? Who's hacking my internet-connected front door lock? Perhaps open question as to how seriously you're treating security for devices that are going to be in the field for 20, 30, 40 years.
We can't really avoid that. We're very humble about the exposure that our infrastructure has. There are federal regulatory requirements which are becoming much, much more important. There are requirements coming from customers that your infrastructure needs to meet these certifications, and that's a rising bar, or else we can't afford to build it into our infrastructure because we can't afford the risk of it being compromised. You can't guarantee, sadly, I don't think you can guarantee security because it's a very complex, as you know, multi-dimensional problem. But attestation, is that really the device that I think it is? Or is it still the device that I thought it was? Is a big issue and something that you'll see us address in a series of moves. It's a very critical problem, I think, that all of us face that have to do with anything that gets put out into the real world.